Chapter 1: The Hidden Frequency. You lie still as an unseen rhythm brushes against your skin, gentle as dawn mist. Beneath the humdrum of daily life, a hidden frequency pulses at 50 or 60 cycles per second, the familiar cadence of alternating current. Each oscillation reverses direction, a silent pulse of energy flowing through wires in your walls. You notice this steady beat as if it were a quiet heart within the building. In that hush, you sense a promise. Even the mundane holds secret movement. Your curiosity leads you to a transformer's copper coils, where magnetic fields dance in silence. According to Faraday's law, a changing magnetic field creates an electric current, coaxing electrons to glide through metal in graceful arcs. You imagine each coil as a spiral galaxy of tiny, charged particles, orbiting invisible forces. The conductor's copper strands hum with potential, waiting to release light or warmth. In this gentle architecture, you learn that energy is never static. It shifts, transforms, and flows like a quiet river. You follow the current onward into the network of circuits that crisscross cities. In a closed circuit, electrons move in loops at speeds approaching a fraction of light, though their drift remains gentle and patient. Each appliance, each glowing lamp, draws from this collective pulse. You sense how resistance in wires warms them, a simple truth of Ohm's law. Even as electrons encounter obstacles, they continue their journey, reminding you that persistence brings illumination, both in power lines and in your own thoughts. In the hush between cycles, you feel a subtler vibration, the Schumann resonance of Earth itself, a low hum around 7.83 Hz that links sky, soil, and sea. This global heartbeat reminds you that every system, from lightning storms to your own brainwaves, shares a common language of frequencies. You realize that listening deeply reveals gently hidden harmonies all around you. If you attune your awareness, the next whisper arises beyond the current's glow, calling you toward a fresh frontier of sound and light. Chapter 2: The Whispering Cell. Your fingertips hover over the glass vial cradling gleaming metallic plates. Suspended between earth and sky, it measures barely an inch, yet holds within it a hidden world. You feel the quiet hum of potential difference, the tension between anode and cathode that defines every battery cell. In this moment of stillness, you become aware of the thin barriers of separator keeping charged plates apart, like silent hosts in an ancient temple. In the heart of this crystalline vessel, ions drift through a liquid electrolyte, migrating in gentle tides. You imagine lithium ions dissolving at one plate, traveling through the medium, then resting at the other side. This movement creates an electric current, invisible but real. A simple redox reaction, reduction at the cathode, oxidation at the anode, allows chemical energy to transform into electrical pulses that power small devices around the world. Each ion's journey follows basic rules of attraction and repulsion, reminding you of the subtle forces that shape everything you experience. You notice ambient glow dancing across the glass. Faint light carries photons that brush against the cells, nudging electrons free in a slow dance. This radiant whisper reminds you energy flows from sun to circuit harmony. As you watch, A spike of voltage pulses through a connected wire like a soft heartbeat echoing in silence. Electrons flow swiftly through conductive pathways, racing at a fraction of light speed to meet their distant partners. This flow of charge is what we call current, and its steady rhythm powers motors, lights, and circuits. You sense every fluctuation as a pulse of life, as if the cell itself remembers ancient cosmic rhythms etched into matter when the universe first unfurled. There is something almost sacred in how energy weaves between chemistry and physics, how simple materials become reservoirs of power. You close your eyes and feel the electric field surrounding the plates, a gentle embrace that primes you for deeper discovery. The cell's whisper grows fainter and more inviting, drawing you forward toward mysteries yet untold. Chapter 3: The Eternal Coil. You cradle a slender copper coil in your palms as if holding a quiet promise. Around its loops, tiny magnets circle like silent moons tracing invisible paths. Each magnet carries a dipole field, a north seeking south, creating lines of force that shimmer between curves of metal. In the dim glow, you sense a gentle embrace of magnetic dance, unfolding without hurry. As you tilt the coil, electrons awaken. They drift through copper strands when a magnet's field changes, generating an electric current. This is Faraday's insight. Motion within magnetism gives birth to flow. You imagine each electron stepping softly from atom to atom, guided by shifting magnetic lines, weaving a river of energy beneath your fingertips. The coil's spiral shape enhances this story. With each loop, the field reinforces itself, concentrating strength within the winding. You see the field lines stacking like layers of mist, intensifying the pull at the core. Here, the magnetic flux grows stronger, measured in Webers, and you feel how geometry commands the invisible, how design shapes force in a silent choreography. In this steady rhythm, motion and magnetism become partners. As you move the magnets faster, the current rises and the coil hums with potential power. You sense how generators on distant hills spin turbines to light cities, how transformers transfer energy across vast networks. Through such simple principles, the world pulses with electricity born from magnetic whisperings. You rest the coil beside you and close your eyes, feeling a delicate oscillation through your fingertips. In this silence, you sense gentle vibrations traveling along copper, echoing in the stillness of your mind. Each loop holds stored promise, a sleeping gale of energy poised between motion and rest, waiting to stir at the slightest breath of force. You realize that every turn, every line of force, is part of an endless circuit. This weaving of motion and magnetism carries you onward into deeper currents of discovery and quieter questions, inviting you to follow a new rhythm into the next chamber of power, ever softly echoing around you. Chapter 4: The Glass Menagerie. You stand before a shallow vessel ringed with concentric circles of glass, each rim catching lamplight like quiet halos. You breathe in the hush around water's secret geometry. Beneath your fingertip, tiny ripples reveal the angle of hydrogen bonds, close to 104.5 degrees, shaping every droplet. This precise arrangement holds water's strength and fluidity in balance. You trace the subtle curvature where molecules cluster, an elegant lattice that forms and reforms with each gentle wave. In a quiet lab beneath your steady gaze, electrodes dip into this crystalline pool. You feel a gentle tingle as a low current teases molecules apart. Hydrogen atoms drift toward one plate, oxygen drifts toward the other, carried by invisible currents of charge. You imagine electrons flowing like soft footsteps between phases. With each split, you witness the birth of fuel. Two hydrogen atoms ready to ignite possibility, and oxygen poised to drift away on silent wings. You watch tiny gates in molecular membranes open, letting water and ions pass in choreographed rhythm. Each opening feels like a heartbeat, sodium exchanging with potassium, protons tiptoeing across membranes in cellular chambers. Here, chemical gradients store energy like compressed springs. You sense the potential difference, measured in millivolts, powering life's subtle machinery. Every pulse resonates, reminding you that transformation begins with a single, precise release of bonds and a spark of organized motion. In this delicate ballet of science and wonder, water reveals its dual nature, both fuel and flame, both calm and fierce. You sense the hidden alchemy at play when molecules collapse into new patterns, releasing energy like soft implosions that ripple outward. Under your breath, you marvel at the unseen link between structure and power. The glass menagerie you observe is alive with possibilities, whispering secrets of transformation. And as you watch the molecular dance settle, you anticipate the next quiet revelation of implosion's heart. As bubbles drift skyward, you hold space for what emerges next, a stillness charged with potential. The mirror reflects new questions. How will liberated atoms converge in the dance? You feel curiosity's soft pulse guiding you forward. Chapter 5. The Silent Implosion. You stand by a shallow basin as water spirals. You notice each droplet drawn toward the center, carrying its small share of momentum into a spinning dance. In these revolutions, you witness conservation of angular momentum. As the circle tightens, speed increases and core pressure drops. In this moment of observation, science and serenity merge, inviting you to feel the quiet power of fluid motion. Your fingertips hover near the edge, sensing the pull of the implosion. The water's surface curves inward, forming a funnel. At the funnel's throat, pressure is at its lowest, drawing molecules closer and converting random motion into focused energy. You feel this transformation as a hushed invitation, a subtle contraction of space that seems to fold boundaries into a single point. Under the surface, eddies swirl in tiny whirlpools you cannot fully see. Each microvortex creates shear forces, spinning layers past one another and generating gentle heat through friction. This laminar to turbulent transition is a real process you can almost touch, a secret ripple beneath the quiet pool that reminds you energy cannot vanish, it only changes form. As you gaze deeper, each small vortex glows like a pearl of power, polished by motion and mystery. The liquid world reveals how torque multiplies when radius diminishes, sharpening the spiral and intensifying the implosive force. It's a scientific truth wrapped in poetic motion. Energy folded inward, waiting to release in a new pattern. In some regions of the vortex, pressure drops so low that tiny vapor bubbles form and collapse. This cavitation releases a focused pulse of energy, echoing the implosion on a miniature scale. though it can erode metal in engines, here you witness a microcosm of change. Life swelling and subsiding, carried on the breath of fluid dynamics. Now you sit with the silent powerhouse, breathing in the resonance of pressure. There is no roar, gentle echo as boundaries slip away. You realize that beyond this silent collapse, where unseen currents converge, something subtle awaits curiosity. Pressure itself is a scalar field, whispering information around you. And beyond this silent collapse, what scalar patterns shimmer unseen? Chapter 6. The Scalar Constellation. You stand at the cusp of a silent expanse, where invisible waves weave an interlaced tapestry around you. A scalar field envelopes space like a temperature map that holds only magnitude, no direction. You notice the subtle rise and fall of potential, as if the universe breathes in gentle pulses. Each fluctuation is a calm breath you share with the cosmos, reminding you that fields exist everywhere, unbounded by shape. As you follow the lattice through darkness, you feel nodes of strength where waves overlap. In basic physics, superposition means waves add together, creating peaks and troughs. Here, at every crossing, energy heightens without a visible vector arrow, as though numbers on a grid glow in moonlight. You trace each line with your awareness, aware that scalar waves carry information differently from their electromagnetic counterparts. Where lines intersect, you sense a current stir, an echo of potential difference, just as a simple battery pushes charges along a circuit. You imagine the universe itself as a grand cell, charging and discharging across hidden plates. This unassuming electric tension hums softly, a private cadence in your chest, reminding you that energy can shimmer without sound. Deeper in the mesh, the geometry feels curved by unseen weights. In relativity, mass and energy warp space-time, bending the paths that light or particles must take. Here, you perceive similar shifts, roots that ripple forward and backward, blurring your sense of before and after. Time folds gently against itself, painting a promise that every moment is both new and familiar. Above, the lattice extends into cosmic depths like a scaffold for galaxies. Consider the cosmic microwave background, a scalar imprint from the Big Bang, with a uniform temperature of 2.7 Kelvin. Tiny fluctuations in that field seeded stars and galaxies. You sense those ancient quantum ripples echo creation. Your fingertips brush the lattice edges, sensing a faint glow at each turn. In electronics, diodes guide electric current one way, converting light into charge in radiant diodes or LEDs. Soon, you will follow these ethereal conduits, watching photons transform into silent currents. What ethereal conduit awaits you in the realm of radiant diodes? Chapter 7. The Ethereal Diode. You hold a slender module glowing softly between thumb and forefinger, its casing warmed by the gentle polarity within. A diode bridges two realms of matter, P-type and N-type silicon shaped at a microscopic scale. This tiny p-n junction stands ready to guide electrons along a defined path, its light emerging where current finds permission to flow, steady with precise intention. In your palm, you sense each pulse of charge as a quiet heartbeat. The diode's emission flickers in gentle bursts, each followed by a brief pause. These pulses resemble ripples spreading across a calm pond after a stone's release. Electric current, measured in milliamps, is barely perceptible here, yet you feel its rhythm as a dialogue between energy and silence. You watch as the diode opens and closes, its junction acting like a one-way gate for electrons. When forward biased, it welcomes a flow of charge. Reverse bias, it seals the channel. This switching effect underpins countless circuits, from radio receivers to solar cells. Each cycle confirms a simple truth. Semiconductors transform randomness into directed purpose. It shapes modern computing. Beneath these pulses lies a whisper of the quantum mist. In the infinitesimal space between electrons and holes, fleeting fluctuations of virtual particles occur. Physicists describe this zero-point energy as the restless hum of the vacuum. The diode harvests a fragment of that playful uncertainty, translating it into organized emission that you can glimpse with wonder. It unfolds quantum secrets. A quiet click echoes when you adjust the current, recalling tales of forbidden laboratories where researchers pursued new materials in secrecy. You imagine early microfabrication rooms, magnifying lenses capturing atomic patterns. Those hushed breakthroughs birthed our modern electronics, each crystal lattice meticulously engineered to guide, store, and remember. Doping, deposition processes, etching converge into patterns of logic and light. The module's crystalline heart holds this charge like a keepsake. Ferroelectric domains or phase change filaments will archive the flow of electrons as memory. In that luminous blink, you feel a bridge between ephemeral particles and enduring structure, a reminder that energy can leave a lasting imprint on matter, waiting just beyond the next threshold. It hums toward hidden structures awaiting discovery. Chapter 8. The Memory of Matter. You hold a pale quartz crystal against the moonlight, sensing a quiet heartbeat in its facets, an ancient hum. Beneath your fingertips, silicon and oxygen atoms form a repeating lattice that extends without end. Quartz is silicon dioxide arranged in trigonal symmetry, each atom nestled with precision. You imagine the rigid network as a scaffold, holding space for silent, subtle vibrations that echo through time. You press lightly and feel the crystal flex, a secret known as the piezoelectric effect. Force rearranges charges within the lattice, creating a tiny voltage at its edges. Piezoelectricity is the principle behind quartz watches and ultra-sensitive sensors in medical devices. Here, each subtle compression and release becomes a measured impulse. You sense how mechanical energy transforms into electric whispers, a dance of geometry and charge that feels like conversation. You trace the lattice further and find lithium ions nestled in tiny channels. In rechargeable batteries, these lightweight ions shuttle between electrodes, carrying charge like water through a bamboo grove. Inside certain crystals, lithium can remain fixed, a vault imprisoning electric energy for years. This stability inspires memory devices where structure itself acts as a container. You feel the gentle stillness in every cell, a promise that energy and history can coexist. In each crystal cell, you sense potential light waiting to be freed. Some crystals luminesce when excited, releasing photons in delicate flashes. Photonic structures guide light like rivers within solid rock. You appreciate how geometry can control wavelength, trapping certain colors until a slight disturbance sets them free. It feels as though the crystal remembers every beam that touched it. encoding moments of illumination in its quiet core. You remember that quartz crystals vibrate at precise frequencies, often 32,768 cycles per second in a watch, a bridge between microscopic motion and our human sense of time. Each tiny oscillation feels like a heartbeat, unwavering. In these rhythms, past and future meet. You almost hear their click, a gentle lullaby echoing in crystal corridors. You watch the soft glow of pulsing charges and memory quietly entwined. The crystal held whispers of light and energy until now. You wonder what rhythmic pulse will emerge from capacitors beneath a moonlit sky. Chapter 9. The Pulse Before Midnight. You stand in the hush of a dimly lit lab, tracing your breath as you approach a simple metal object. Two thick flat plates face each other, separated by a silent gap. When you touch the smooth surface, you sense stored potential, like a secret heart waiting to unfold. You feel curiosity stirring as the plates gather electric charge, quietly building tension in their embrace. Gently, you remember that a capacitor stores energy in its electric field. Two plates hold opposite charges until the field between them becomes strong enough to balance attraction and repulsion. This field obeys Coulomb's law, pulling and pushing in equal measure. You imagine invisible lines of force weaving between the plates, a delicate lattice of energy holding its breath, precise and alive. Slowly, you guide a gentle current through the circuit, watching the plates fill with opposing charge until they whisper to each other in silence. You picture a water lily bud, petals closed in darkness, petals waiting for a night bloom. Like that flower, the capacitor's energy is held in a poised hush, each volt adding a new layer of possibility. You feel tender anticipation stirring in your chest. In an instant, you close the switch and witness a gentle crack as electrons rush between plates. The rush obeys Kirchhoff's laws, conserving charge as it flows. You sense a brief echo, like a soft exhale, when the field collapses and energy leaps free. For a heartbeat, you feel the current singing through the wires, alive and fleeting, a singular pulse that dissolves into stillness. You pause, listening to the silence that follows, noticing how the air seems to welcome the absence of motion. In that gap, you glimpse the boundary between stillness and change. It reminds you of atoms in a solid lattice that vibrate around fixed positions, only shifting when heat or force compels them. Here, energy rests until curiosity or need stirs it to bloom once more. Tonight, you wonder what fusion of atoms will finally hush the world's longing for endless power. You close your eyes, feeling the pulse still echoing inside you. In this gentle wandering mind, you sense the next great secret waiting to unfold beyond horizons of time. Chapter 10. Into the Stillness. You stand before a slender chamber glowing softly inside. Its stainless steel walls cradle a delicate dance of palladium and heavy water, waiting. A gentle hum vibrates beneath your feet like a resting heartbeat. In this threshold of quiet, anticipation feels more electric than light, and possibility fills the air. Within that lattice, deuterium ions slip into interstitial spaces, threading through atomic corridors. Each nucleus carries a peaceful energy, drawn by careful pressure and cooling. You sense the subatomic dancers pirouetting inside microscopic halls. Here, real science meets poetry. Palladium's crystalline structure behaves like an open gate, offering passage to particles too small to see. Under cryogenic temperatures, deuterons slow and crowd together. Occasional quantum tunneling allows them to approach distances where nuclear forces whisper. You learn that cold fusion attempts to overcome repulsion with collective behavior, enabling occasional fusions without a roaring sun. Scientists measure tiny excess heat, proof of soft nuclear interactions and potential clean energy. You notice sensors glinting on the chamber's exterior. Thermocouples measure slight temperature rises with millikelvin precision, while scintillation detectors catch fleeting gamma flashes. Each instrument listens to particles in real time, translating subatomic events into data you can understand. In that conversion, pure phenomena become gentle signals within the human realm. As you press your palm gently against the chamber's cool surface, you imagine warmth emerging not from flame, but from countless microscopic taps of nuclei fusing. That hum becomes promise. A single fusion releases millions of times more energy per particle than chemical bonds. Slowly, you absorb the wonder that such subtle shifts might power distant cities. In the quiet that follows, you reflect on zero-point motion, the restless jitter of particles that never fully still. Even in absolute zero, quantum fields pulse with latent strength. This invisible backdrop underpins every reaction here. Science whispers that the smallest tremors can reshape worlds. In the silence, your breath aligns with that underlying rhythm. Now, the chamber rests again under steady observation. Your heartbeat slows, matching the frequency of gentle experiments. In this hush, the promise of a battery that never dies feels tangible. Yet beyond this stillness, you sense the first hint of a question unfolding, a soft invitation to the dawn awaiting in the next discovery.